Hi everyone, welcome back. Um, this is our second video on section 3.1. 3.1 is a big section. Make sure you've already watched part 1 of our measures of center video. This one that I'm about to do is part 2. Okay. So if you already watched the lecture from 3.1, part 1, we learned about the mean, the median, the mode, and the mid-range. In this video, we're going to be learning about how to think critically about our data values and think about whether the measures of center that we've calculated are actually useful. That's the first thing we're going to learn about. And then after that, we'll learn how to calculate what's called a weighted mean, or in the real world, a lot of people would call that a weighted average. Remember, you're not supposed to use the term average in statistics or science, even though in day-to-day life, people would call it a weighted average. We want to call it a weighted mean. All right, so this is starting where I left off in this long set of slides from the last video. So if I go ahead and get to where we left off, it's going to be way down here after the mean, the median, the mode, and the mid-range. Okay, so this is the slide that we left off on in part 1. Okay, so I already said this in the last video, but I'm going to reiterate. You can always calculate these measures of center, but you need to think critically about the data that you've gathered and also whether the measure of center that you've calculated is actually useful in the real world, in your study, scientifically, and also mathematically. So thinking critically is important. So let's take a look at some examples of measures of center, and we're going to learn about these in particular are a bunch of examples of statistics that are not actually meaningful for a variety of reasons, mostly because of real world issues. Okay, so part A would be zip codes of a bunch of locations. Zip codes here are 63102, 20500. The thing about zip codes is they are numbers, and you can calculate the mean, the median, the mode, the mid-range. But any kind of statistics you do with these numbers doesn't actually matter, really. It's not useful because these zip codes don't measure or count anything. Rather than measuring or counting something, they're really just a substitute for labels for geographic locations. So the numbers don't have any mathematical or even really any real-world meaning. They're just numbers that were assigned to geographic locations. So for the most part, calculating the average, well, I'm not supposed to call it the average, the mean, the median, the mid-range, the mode, any of that stuff isn't useful if the numbers are basically just nominal. These numbers are nominal. Remember, nominal data is just names, labels, or categories. Okay. Now, here's another example of a situation where you can calculate a measure of center like the mean or the median, but it doesn't mean much. So ranks of selected medical schools of Harvard, Johns Hopkins, New York University, etc. Even though these numbers technically have an order to them, like first place, second place, third place, fourth place, 10th place, that's technically still ordinal, okay? So it's technically not actually measuring or counting something. This is a little bit more in the gray area, but our book says the ranks reflect an ordering because they're ordinal, but they aren't actually measuring or counting anything. So it doesn't really make sense to do calculations with these numbers, because these numbers are really like categories. You know, first place, second place, third place, even though there's an order, those are categories that are in order. Okay. Next one. Another example of a problem that we've seen in earlier videos, numbers on the jerseys of the starting offense for the New England Patriots. I don't know why there's a dash there. You know, that's bugging me, so I'm going to fix that right now. New England Patriots. Okay. When they won Super Bowl. Okay, so these numbers are just the numbers on the shirts of football players. And remember that these numbers don't mean anything. So if you calculate the mean, the median, the mid-range, the mode, you can calculate those things, but those measures of center don't tell you anything because these are nominal. These are numbers, but they're numbers that are just a substitute for names. They don't even have an order that has any meaning. Right? You could write the numbers in increasing order, but that probably won't tell you anything because they're just usually arbitrarily assigned to different players. Okay? So what we're getting so far is that if your data is nominal or ordinal, in other words, if it's not quantitative data, in part A, B, and C here, you can calculate statistics like the mean, the median, the mid-range, and the mode, but they don't mean anything. They're not mathematically useful, and they're also not useful in the real world. Okay, part D, another example of meaningless statistics. The top 5 annual compensation of chief executive officers in millions of dollars. So $513.3 million, $256.0 million. Now this one's probably a little bit harder for you to understand because these numbers are technically the ratio level of measurement because they have a true zero, which would mean if they made $0 per that year. These numbers are measuring or counting something. But the problem with this one is the way that the data was gathered. Top 5 or top 10 lists include data that are not at all representative of the larger population. So our book makes the argument here that because it's the top 5, we haven't randomly selected chief executive officers from the population. We've just chosen the top 5. So the reason that's not meaningful statistics is you're just looking at the very top, and so it's not really a random sample, which is how you're supposed to gather your data. So this doesn't actually mean anything. You can calculate the mean, the median, the mid-range, and the mode, but it's just going to tell you the center for the top 5. It's not going to tell you anything about, the average compensation of chief executive officers, So as you can see, top 5, top 10, top 20, anything like that is going to end up being pretty much meaningless in most cases. Even though these numbers are technically ratio level of measurement, the measures of center don't mean anything because we aren't randomly selecting chief executive officers. Instead, we're only selecting the top 5. Okay. Part E is even more challenging to understand. This is another example of not meaningful statistics. Okay, the 50 mean ages computed from the means in each of the 50 states. Okay, so they're talking about ages, and remember that someone's age is measuring or counting something. So that technically would be the ratio level of measurement because you can't have a negative age. So it has a true 0, okay? But even so, our our textbook argues that if you calculate the mean of those 50 values, the result is not the mean age of people in the entire United States. Okay, so there's an issue there, which is that instead of randomly selecting people from the United States, they calculated the average or the mean age for each state individually. Okay, so what's wrong with the way that they gather their data? The result is not the mean age of people in the entire United States. Instead, what they were supposed to do is the population sizes of the 50 different states needed to be taken into account. So if you're going to do it this way, you can't just add up the average for each state because different states are different sizes. The number of people living in California is way more than the number of people living in, for example, Maine. So because of that reason, this is meaningless. However, what you can do in this situation is if they did take the population sizes of the 50 different states into account, then they would be calculating what's called the weighted mean, which is actually something that is a meaningful statistic. So if they assigned a weight based on the population size, the number of people living in each state, then they could have calculated what's called a weighted mean, and that would be very useful. So that's actually the other thing, the main thing that we're going to be learning in this video, that's really math. Okay, so weighted mean. Let's take a look at this. Calculating a weighted mean, this formula might look a little intimidating to some people, but we're going to break it down. It's actually not too bad. So weighted mean is a way of calculating a measure of center when different categories usually have percentage or decimal values. Okay, so if different data values x are assigned different weights w, we can compute a weighted mean using this formula. So x bar is actually here it's representing a weighted mean, and in the numerator we have the sum of each weight times each data value. So we do the weight times the corresponding data value and we add them all up in the numerator, and then in the denominator all we do is the sum of all the weights. So we add up all the weights in the denominator. And if this formula looks abstract, that's okay. We're going to do an example right now. Okay, so we'll come back to this formula, but let's see an example. Now, these weighted averages are actually very useful for a lot of things in the real world. I already mentioned this, but our first example is going to be on computing grade point average. So granted, your computer might do this automatically for you, but if you wanted to calculate someone's grade point average by hand, this is how you would do it. This is a very real world problem. So in her first semester of college, a student of the author took 5 courses. Her final grades, along with the number of credits for each course, were she got an A in a course that was worth 3 credits, another A in a course that was worth 4 credits, a B in a course that was worth 3 credits, a C in a course that was worth 3 credits, and an F for a course that was worth 1 credit. So the thing is, you have to realize something. A, B, C, D, F, you can actually assign numbers to those letters. So even though they're technically ordinal, so they're technically categories that have an order to them, here we are going to assign numbers to those letters, and these are the standard numbers that are assigned to the letters. So A is 4, B is 3, C is 2, D is 1, F is 0. these numbers do have mathematical meaning because those are the numbers that you're supposed to use when you're calculating your grade point average. So the book calls the grading system quality points. That's just a name for those numbers. So how do we compute the grade point average? Well, we use this formula, x bar, here x bar is the weighted mean, equals the sum of the weight, each weight times each data value. You add them all up, and then you divide by the sum of the weights. Okay? Easiest way to figure this out is you have to figure out, first of all, what the weights are, and then also what the data values are. So what do you think the weights are? Do you think the weights are the number of credits, or do you think those are the quality points? Think about that for a second. You can pause the video if you need to. Okay, so actually the weights here are going to be the number of credits. Okay, so the weights are the number of credits, and then the quality points, the letter grades converted into numbers, are going to be the data values. And that should kind of make sense because your grade in a course is sort of like a data value in a way, whereas the number of credits tells you how important that course is when calculating your grade point average. So it should make sense that the number of credits is like a weight. It is a weight, okay? So here, let me just write it out. I don't want to go to the next slide because all the answers are written there. So I think, yeah. So, okay, so we got the weights here. I'm just going to write W for the weights. And those are going to be the number of credits. So here we have, you have to do them in the right order, by the way. So in the order they're written here, 3, 4, 3, 3, 1 for the number of credits. 3, 4, 3, 3, 1. Those are the weights. And then here, her grade in each course also has to be in the same order for this formula to work. So in order, the grades she got, we need to convert these to numbers. So A for the 3-credit course, that's the same as a 4.0 on that course, but we're just going to write 4. There's no need to write the 0.0. So that was an A, which is a 4 for the first data value. For the second course, she also got an A, so that's going to be a 4 or a 4.0 there. Then she got a B on the 3-credit course. So remember that a B is worth 3.0. Okay, a C, which is a 2.0. So here we're writing a 2. And then an F. An F is actually worth a 0 when you're calculating a grade point average. Okay, so here the weights are going to be the number of credits. And your first homework problem on weighted averages is very similar to this. Basically the same idea where you have different courses with different number of credits, and you can follow this exactly. It's just going to be different numbers really. Okay, so weights, number of credits. Here, the actual grades need to be converted to numbers. And then we use the formula. So the formula, I'm going to have to switch off the slides so I can write on this. Okay. So the formula for the weighted mean, unfortunately our book uses X bar for the weighted mean, but they also use that for the sample mean. But that's okay. X bar is going to be the sum of each weight times each data value. So the sum of parentheses W times X and parentheses all over the sum of the weights. So what's that going to look like here? Obviously I need to write smaller over here. So all you have to do is once you have them written down like this, W x. The numerator means we multiply each w times each x. So we just have to go down that column and multiply. So the first one here is going to be, let me just circle it, 3 times 4. Okay, so we have 3 times 4. Okay, and then the next column is going to be 4 times 4. And then because it's a summation, we need to add these up. So it's going to be 3 times 4 plus 4 times 4, and so forth. So the next one is going to be 3 times 3, and then 3 times 2, and then the last one is going to be 1 times 0. Okay, that is the numerator. All it means is you multiply each weight times the corresponding data value x, and then you add all those up. And then the denominator is easier. So this just means the sum of all the weights. So for our denominator, all we have to do is add up all the w's. Okay, so it's going to be 3 plus 4 plus 3 plus 3 plus 1. 3 plus 4 plus 3 plus 3 plus 1. And I know this is all worked out on the slides, but when I'm actually teaching you math, I like to just write it down. I don't know why, it just feels better that way. Okay, so if we plug this stuff into our calculator, the way most people would do this on their calculator is they would type in the numerator here first, and then they would type in the denominator, and then at the end they would divide. You could technically type all this in all at once, but if you do type it in all at once, you would need to put parentheses around the top and parentheses around the bottom. Otherwise, your calculator won't work properly. Okay, so that's just if you want to enter them in all at once. But what most people do for these is rather than entering them in all at once, they just focus on the top and the bottom separately, and then at the end they divide. So the standard way would be, on my calculator, I do 3 times 4 plus 4 times 4 plus 3 times 3 plus 3 times 2 plus 1 times 0. And that actually gives me, when I type all that in and then I press enter on my calculator, that's going to give me 43 for the numerator. Okay, so the numerator is going to be 43. And then in the denominator, we add up all these values on our calculator. So 3 plus 4 plus 3 plus 3 plus 1 gives us 14 for the denominator. So we have 43 over 14. And then we just go ahead and do this division on our calculator. So 43 divided by 14. 43 divided by 14 gives us 3.0714. 3.0714. And then normally with the weighted mean, you want to use the standard round off rule where you round to one more decimal place than what you started with. But because this is a special case, here we're actually doing a grade point average. So here we're calculating a grade point average. In this special case, the way people usually do grade point averages is they usually round to 2 decimal places. So for example, you could have a grade point average of 2.71 would be the standard way of writing it. So that's rounded to 2 decimal places. So we're going to kind of break away from that round off rule just because this is a special case of a GPA. So this is going to be rounded to 2 decimal places. So that's a GPA of 3.07. Okay. If we were following the round off rule, then it would be rounded only to 1 decimal place because that's 1 more than the number of decimal places that we started with. So if we follow the round off rule, we might write 3.1. But because it's GPA, you probably know that GPAs are always written in this format. rounded to 2 decimals. Okay, so that's a pretty cool example of a weighted mean. Pretty stoked about that, and my writing looks a lot better on the board now that I'm getting used to it. Okay, so I'm going to erase this stuff, and we're going to look. The book did it exactly the same way I did, as you can see in these slides. And then, so they did the same thing. So the number of credits was the same as the weights. And then the letter grades were replaced with quality points, and those were the same as our data values X. Now, grade point averages aren't the only type of weighted mean, or, we want to call it a weighted average, but we're technically not supposed to. It's supposed to be called a weighted mean. Anyway, there are other kinds of weighted means. Another very common way that weighted means are used, especially by students or professors, would be that rather than calculating a grade point average for a whole semester, haven't you ever wondered, well, I'm taking some course and I'm looking at the teacher's syllabus, and the syllabus, it says, quizzes are worth 20%, homework is worth 30%, and then the exams are worth 15% each, or whatever grading scheme that they have in their particular class. You might have asked many professors before, what is my grade? And they might have told you, well, you can calculate your grade, but you might not have known how to do that. So how do you calculate your grade when you have percentages? Well, you use exactly the same formula. Okay, so we're still going to use this formula. The weighted mean is still the sum of each weight times each data value. You add those all up, and the denominator is still going to be the sum of the weights. So I think I have time, so I'm going to go ahead and give you a bit of a homework tutorial now. So I need to go ahead and open up MyLab Math. I'm doing that over here. And then I'm going to go ahead and bring that over to this screen. Okay. And while I'm doing that, I think I'm going to tell you a joke to deal with the awkward silence. Because right now I'm just in this recording room. Anyway, do you guys know what a photon is? A photon is a particle of light. So the joke I wanted to tell you today, while I'm waiting for this to load, is where do photons go to jail? And if you want to think about that joke, you're welcome to pause the video before I tell you the punchline. So where do photons go to jail? They go to prism. Prism. It's a light sentence. Okay? Well, hopefully somebody laughed somewhere. Okay, so what I wanted to do now is I have this open now, so I'm going to go ahead and close these slides here, and then I'm going to switch to this is actually one of your homework problems. Okay, so one of your homework problems right here. Let me zoom in so we can read it. So now when you're doing your homework, you're going to find that you actually have different numbers in these, but it's going to be a similar kind of question. It's just the percentages will be different, and then also the actual scores are going to be different. So different numbers, but it's going to be the same setup. Okay, so let me go back to that. So here we have a student's course grade is based on one midterm that counts as 15% of his final grade, one class project that counts as 10% of his final grade. Sorry, I'm trying to make this look better so that we can see. Okay, that helps a little bit. Hopefully you can still read that. Midterm, 15%, class project, 10%, homework, 35%, final exam, 40%. Okay, and then they have his scores. So midterm score was 72, project was 87, homework was 81, final exam is 68. And they're asking, what is his overall final score? In other words, the student's wondering, what is my grade? And if the professor tells you, well, you can calculate your grade. It says the percentages in your syllabus. This is how you do that. That's what we're going to do here. Okay? So, I'm going to go ahead and write down the information here. So first of all, I want you to kind of look. Let me switch back to this view. There we go. I want you to look at these and think about it. What do you think the weights are here? You're welcome to pause the video. What are the weights and what are the data values? Let's see if you can think about that on your own. Pause the video. And then once you've decided, go ahead and unpause. So the answer is the actual weights are going to be percentages. And you can either leave them as percentages or you can convert them to decimals. But you technically don't have to convert these percentages to decimals, so I would recommend that you just leave them the way they are. So here the weights are actually going to be the percentages of each category. And then the data values X are going to be the same as the student's score in each category. Okay? So, remember, if you want to do it the way I taught it, probably the easiest way. Just thinking where to write this so that you can read it. So I'm going to write it right here. Okay, so W is the weights. And here W is going to be, well, we have to do them in the right order here. So midterm comes first. That's 15%. That's the first weight. Class project is 10%. Homework is 35%. And the final is 40%. Who better not miss that final, huh? So those are the weights. And then we've got scores. The scores are the same as the data values here. So X will be the scores. So his midterm score was 72. His project score is 87. His homework score is 81. And his final exam score is 68. Okay, notice that these are in the correct order. So in order for the formula to work, you have to have these things lined up properly. So the weight has to correspond with the corresponding data value, which they do. So in order, we did midterm, project, and then we did homework, and then final. So these are in the correct columns here. And then we can just go ahead and do the formula. Okay, so now we have that all written down. I'm going to switch to the camera. So we're going to be doing, once again, a weighted mean, and we're going to use the exact same formula we did for GPA. Okay, so weighted mean is, they use X bar in our book for it. The sum of W times X all over the sum of W. Okay, so what's that going to look like here? Actually, I think I'm going to write it down here so I have more room. So X bar, weighted mean, is going to be the sum of each weight times each data value. And because they're all lined up, we're just going to do the same thing we did before. So the first one is going to be 15 times 72, and so forth. and then we add them all up. So 15 times 72 is the first column, plus 10 times 87 is the second column. Third column, 35 times 81. And then the last column is going to be 40 times 68. So plus 40 times 68. And then this is all over the sum of the weights. So adding up all the weights here, we've got 15 plus 10 plus 35 plus 40. So 15 plus 10 plus 35 plus 40. And by the way, because these weights were representing percentages, these need to all add up to 100. These weights need to add up to 100. But remember that there are other kinds of weights, and your weights don't always have to add up to 100. The only reason these weights add up to 100 is because they're percentages. And if you add up all the percentages for a course, they need to add up to 100% of your course grade. That's why they add up to 100 here, but they didn't actually add up to 100 in our GPA example, the last example we did, because those weren't percentages. Okay, so then, once again, if you're good with your calculator, you might be able to just type this all in at once and then press enter. But once again, if you're doing that, on most calculators, for it to give you the correct answer, you are going to need to put parentheses around the numerator and the denominator. And then, of course, what most people do is they just type in the top and then they type in the bottom separately. So that's what I'm going to do. Okay, so the numerator, I'm typing in 15 times 72 plus 10 times 87 plus 35 times 81 plus 40 times 68. That gives me 7,505. 7,505 in my numerator. And then in my denominator, what do we expect this to add up to? It should add up to 100 since these are percentages. So either in our calculator or if you can do it in your head, 15 plus 10 is 25, plus 35 is going to be 60, plus 40 is 100. So we should have 7,505 divided by 100. And then you can do that on your calculator if you don't want to worry about it. Just type in 7,505 and then divide it by 100 and then press enter. But this is easy enough. Some of you might know how to do this in your head. If you're dividing by a power of 10, you can just move the decimal all the way so that's in front of the 1 here. And basically the number of zeros is the same as how far you move the decimal over here on the top. So here we start on the right side and we move the decimal over 2 places because there were 2 zeros. That's how you would do it without a calculator. Okay, so that's going to give us, either with a calculator or without, you should get X bar, the weighted mean, is 75.05. Okay, this is the student's score, total score in the class. And then to figure out their grade in the class, all they have to do is convert this score into a letter grade. And of course, if your professor has like a curve or a different grading scheme than usual, it's possible that this would be something other than a C. But if they're using the standard grading scheme, then this would definitely be a C, because from 70 to 79 or 79.5, depending on the professor, is usually means a C. And anyway, if you're doing your homework, they tell you about all this, so you don't have to, worry about it too much. So let me switch back to this view. There we go. Okay, so his overall final score is, it says type in integer or a decimal, do not round. So that's going to be the number that we just got there. What was the view that I got that looked a lot better than this? Oh, there we go. Okay. So we got 75.05 because they didn't say to round. We're just going to go ahead and type that in, 75.05. Sorry, I'm still figuring out how to press all these buttons here. Okay, so 75.05, check answer. Fantastic. My math lab is always very encouraging. I love the praise that it gives us. Okay, and then his letter grade is, well, if you look at the information that they gave you here, they just want you to use the standard grading scheme. Okay, so actually I'm just going to use the cursor because this is way too hard to see. So they're asking us what letter grade did he earn? A, B, C, D, or F. Obviously this is a C, right, if you're using the standard grading scheme. But why is it a C? Well, because of this information here. So they say assume that a mean of 90 or above is an A, a mean of at least 80 but less than 90 is a B, and then of course that would mean that a mean of at least 70 but less than 80 is a C. So his letter grade is a C. Okay, but once again, that's the standard grading scheme. If your professor curves the class at the end or curves each exam or whatever they do, it might not necessarily be a C, but here that's just the standard grading scheme. Okay, pretty cool, huh? So I think you were able to do all your homework now. That was a lot of videos I just made. I just made 3 videos in a row. I think I'm gonna go home and relax. So thank you for watching, and I will see you guys next time.